Hey boys, today I want to look at mixed numerals in particular and how we work with mixed numerals, especially when we're like adding mixed numerals in common fractions. So you can see on the screen here, I've got 3 holes, and my holes are represented by the black rectangles that you can see. And you can count for yourself and see that each of those holes is broken up into 1, 2, 3, 4, 5, 6 parts, 6 all the way along. So I know straight away that if we're talking fractions, I'm going to be talking sixths, something over 6. I don't know why I picked 6 as my example. I hate saying sixths. It sounds so strange. But anyway, we're going to go ahead and count up how many sixths are highlighted in green here. So I can see there's 6 in this hole here. There's another 6 here, which takes me to 12. Then there's 13, 14. So this number is 14 sixths. Now remember, that is an improper fraction. It's an improper fraction because my numerator is greater than my denominator. There's nothing wrong with an improper fraction either. I think sometimes when we talk about them in class, some people think that you shouldn't use improper fractions. You absolutely can. I really like using mixed numerals because I find that it's easier to make sense of what you actually see in front of you. So if I wanted to write this as a mixed numeral, I could do this. I could count how many holes I have. So I've got one hole here that's completely highlighted. I've got another hole here that's completely highlighted. So I've got 2 holes, and then I've got 1, 2, 2 sixths over here. Now I feel like most people are pretty good at counting when there's boxes here. It does get a little bit tricky though when we might say something like this. We might not be able to give you the option to do that. We might take away the boxes and it might just say, you know what, imagine you've got 13 sixths. Write that as a mixed numeral. So we need to work out a strategy for what we can do if we've just got an improper fraction in front of us. How can we work out how to transfer that into a mixed numeral? And the very first thing you need to do is look at the denominator. We've got sixths. So you need to think, how many do I have to make holes? I've got 13 sixths. How many holes can I make with 13? One hole of 6 would be 6 sixths, which means 2 holes is going to be 12 sixths. So I know for sure that I can make 2 holes. Then it's almost like you're doing division. Whatever the remainder is, whatever's left over, that's how much of a fraction of another hole you've got. So in this case, I've got 12 sixths would be 2 holes. Then there's 1 sixth left over, so it's 2 and 1 sixths. I want to get rid of every single thing here and start again. I'm using a bit of a new program for using my touch pen to write on the screen, my stylus, so it will be a little bit slow for me to work out. I want to look at how we add mixed numerals. I did this with my group in my classroom the other day, so I really hope that other guys had a chance to experiment with this. Let's imagine we've got 2 and 1/4, and we're adding 3 and 2/4. I like to approach this, remember this is the correct setting out, we're working horizontally. I like to approach this in 2 parts. I like to add the common fraction first, and then I like to add the holes. The reason why we add the common fraction first is if there's more, like if it adds up to be an improper fraction, then we know that we need to regroup that and set it as a whole. So I'm going to start with fractions. I've got 1/4, add 2/4. That's nice and simple. That's going to be 3/4. And then I add my holes. I've got 2 holes and 3 holes. So it's going to be 5 and 3/4 or 3/4. It does get a little bit tricky though, so let's change pen color when you've got something like this. Let's say we've got 7 and 3/10 plus 2 and 7/10. So again, we're going to start by adding the fractions. 3 plus 7 would be 10/10. 10/10 is 1 whole. So what I like to do is do a little bit, as if we're doing an algorithm, do a little bit of a 1 above my 7 to let me know, hey, there's another whole here that I've got to add. And then I do 7 and 2 is 9, and 1 is 10. So 7 and 3/10 plus 2 and 7/10 is 10 holes. And I can just write it like 10. You don't need to write 9 and 10/10. You can regroup it to look exactly like this. I want to clear it again to show you one other type of question that you might see popping up in tests or in those little bit of harder parts of Stepping Stones or My Maths Online if you're working through it. It's ones that look like this. We say, you know what? Write this. Write 5 and 3/5 as an improper fraction. So it's doing the same thing as before, but almost backwards. The trick that you can use to work that out is to go, well, if I've got things that are broken down into fifths, 1 whole is going to be 5 fifths. So you can use a little bit of multiplication. You can do 5 wholes times 5, because it's separated into 5 parts. So 5 times 5 is 25. That means I've got 25 fifths in 5 wholes. Then you can add 25 onto the 3 that are already there. 25 plus 3 would be 28. So 5 and 3 fifths is going to be 28 fifths. I want to do another one just in case you're sitting there thinking, what just happened? What did he just do? So let's say we've got 2 and 1/2. Nice and simple. If I want to show that as an improper fraction, I need to work out how many halves are there in 2 wholes. To work that out, you do 2 times 2, which is 4. Add on the half that's already there. I get 5 2s or 5 halves. I really hope that makes sense. It does get a little bit confusing when you're working with mixed numerals and common fractions and improper fractions, but if you're pretty good at doing simple addition, if you're really good with your times tables and doing simple multiplications, you will be absolutely fine. Good luck, boys.